Look at the number of deep learning papers being published every year. It's increasing exponentially. In fact, there are over 300 deep learning papers being published every day in 2020. So do you really have that much time to read all of them? I guess not. Wouldn't it be nice if somebody can do a summarization for us, especially when I say somebody, I mean AI, deep learning models. They will be pretty cool if they can generate too long didn't read for us, which contain maybe around 20 words. That will be super helpful. Today, we are going to look at the model that does too long didn't read for you. In fact, Semantic Scholar has already deployed this model. They use the same methodology they proposed in this paper. So hopefully, in the end of this video, you will know how to build your own too long didn't read summarization model so that you can save a lot of time. By the way, I make deep learning explained video every week. So if you would like to receive more relevant videos like this, don't forget to subscribe. And your subscription is also my best encouragement to make more videos like this. This paper was published by Allen Institute for AI and the University of Washington. So what's so special about this paper? Firstly, they introduced the too long didn't read, this extremely short summarization to the AI summarization area. Previously, it wasn't really a focus. And more importantly, they label the data, science too long didn't read. It's a too long didn't read for science papers, which contains over 5,000 too long didn't reads, and on the around 3,000 papers. And they propose a framework of how you can build this model. It's short for CATTS, CATS. The novelty of it is that it uses title as a scaffolding for training signal. So let's look at the science too long didn't read. It contains 5,000 too long didn't reads, over 3,000 papers. And it contains two kinds of TLDR. The first one is author-generated TLDR. They get this from the Open Review ORG website. When the author submit the paper, they also need to submit the too long didn't read in their website. So that's how they collect the data. And another way they collect the data is they use the peer reviews. They hire undergraduate students to rewrite the peer reviews to too long didn't read. And this is how they convert the peer review to too long didn't read. It just looks like this. In fact, it's very interesting idea how they collect this data. And this is some overview, give you some sense of too long didn't read. They highlight this too long didn't read by using these 4 different sections. First one is called A, is subject area, and P stands for problems, C stands for contribution, details, D stands for details. So let's just look at the author-generated TLDR. The proposed framework means the contributions. They propose a framework, which makes sense. And the green color is problem, to learn a good policy through limitation learning. They say this is problem. And let's see the yellow color is detail. This is detail, describe how they do these things, the meta learning, blah blah blah. And also this is a peer review, contributes to a ML based algorithms. So this is kind of a very interesting way to segment the too long didn't read. And details, they are actually, if you look at the text, they're in the same color. They have very, very similar attribute, right? So let's look at this. Basically the same. This is the contribution, evaluate the effectiveness. and this is propose and encoder models. So this is peer review TLDR and the author TLDRs in terms of contribution is quite different. So this is just some detail of that. And we're going to let the model learn this. Okay, so the proposed framework is CAT. It basically stands for Control Abstraction for TLDRs with Title Scaffoldings. Use a title as another scaffolding goal to train a model. Okay, so when they are doing this too long didn't read, they face two major challenges. The first one is limited data size. As you know, that's super hard, super expensive to generate summaries for the text. So that's why they only have 5,000 TLDRs, which is not a lot. Considering if you are going to employ deep learning model, there's an extremely small amount of data. And another thing is, it definitely requires a lot of domain knowledge to generate too long didn't read, because their model can be run on many different domains of science areas. That's just a very, very difficult task. If you are a physicist, maybe it's easy for you to generate too long didn't read for physics papers. But what if I ask you, a physicist, to generate too long didn't read for a social science paper? They may be super hard, right? So it's very hard for humans, not to mention for models. That's why they need more data. They need more data. And title usually, on certain level, summarize the paper in a very significant way. Some people actually say, why do we need to generate too long didn't read? Because title is one kind of too long didn't read. But title contains somehow too little information, but definitely it contains certain information, essential information. So if we can use title as another training objective, learning objective, that will be great, because every paper has a title, right? Then if you use the title as your training goal, you can have a very large amount of data. Okay, depending on how you use it. So let's just look at it. This is the proposed method, CAT. So they get their too long didn't read from their dataset science too long didn't read, which around 5,000. They also get the data from archive, which is the paper title and the paper itself. And when they train the model, they will append a code, a generated code in the beginning of the data. So let the model know, oh, if this is title, means they are going to generate title as a summarization. If this is the too long didn't read, the model is going to generate too long didn't read as a summarization. And definitely when they're doing the training, they're going to shuffle data. So the model sometimes will receive the data that's too long didn't read. Sometimes it receives the data that's title as answer. And you will have maybe very imbalanced number of data points, because you have so many papers on archive, but you only have 3,000 paper in this science too long didn't read data set. So it's depending on how you balance this data set. That's a kind of a hyperparameter that you can tune. When you actually train a model, you will only input too long didn't read or title. So like in this case, you first feed the model too long didn't read and the title, and too long didn't read and the title and the title. So you would use this tag to tell model what kind of summary it should generate. And in the inference time, you will only feed the too long didn't read title to the model. So the model will only generate too long didn't read for you. But in the training time, you will also generate titles. The goal is to let model to have more training signals. Okay, so let's look at the baselines in their experiments. So they select several baselines for extractive methods. One is for unsupervised extractive summarization. It's called PEG-SUM. It's basically the combination between text rank and the BERT. They use BERT as a text encoder for text rank. And another is a supervised one. It's called BERT SumMax. They use the inner sentence transformer layers to let the transformer understand the relationship between sentences. And also match sum. Transformer plus a Chinese network. As for abstractive summarization, they chose BART, which is the state-of-the-art model for XSUM dataset. It's a model that published by Facebook. It's quite popular. It's a transformer-based model, encoder, decoder. Like this, you give the paper, then the model will generate a summarization for you. And they use the too-long didn't read to tune this part. So the input space, which means, do you want to input the whole paper to the model and generate too-long didn't read, or you only want to input a partial paper? For example, only input abstract and the conclusion for the model to generate too-long didn't read. They have two different ways to do things. The first one is to only input abstract, and they calculate how many words are there in their dataset. On average, there are 159 words, and to generate the too-long didn't read, they will have the compression ratio about 7.6. Means this number will be divided by 7.6, and there will be the number of the average words of the too-long didn't read in this data set. And another is called abstract, introduction, and the conclusion. There was a previous study that says these three sections for the paper actually are most important for generating summarization of a paper. So on average, there are 993 words for abstract, introduction, and the conclusion, and the compression ratio is about 47. In fact, this is really similar for my experience. I usually find the abstract is definitely most helpful. In abstract, the context of abstract is very similar to conclusion, and the introduction is also very important for a paper. Okay, before we dive in the experiment results, let's just look at something interesting. So they also calculate the upper bound of the extractive model. They call the oracle. So let's select they use the too-long didn't read, which is the answer, to select the single sentence they has the highest overlap for the golden too-long didn't read. So you use the answer to find the most suitable sentence in the paper for summarization. So that's, you already know the answer. So the sentence they select, the score, the RAG score this sentence has is the upper bound for extractive sentence label model. Okay, another matrix that we need to know is a RAG matrix. It's the way that people use to evaluate summarization results, and people also use this to evaluate machine translation results. So there are three different types of RAG. RAG 1, the overlap of unigram, means how many words they overlap, and the RAG 2 means how many percentage of the bigram they overlap, and the RAG L is more complex. It basically means the longest common sequence. For example, you have two text, then what's the longest common sequence they can match? Okay, then it's exciting experimental time. This is their results for extractive summarization. So this is oracle, means it's a ceiling for them, the upper bound. And the text rank unsupervised one definitely performed very poor because it just didn't really train the model, right? Then the Burr-based extractive model perform quite well, but compared to their proposed model, CATS, it just not even close. I would say the match sum is quite good in the abstract only, but when you feed more data, this match sum cannot perform better. That's weird, right? You see what I mean? When you increase the amount of data in the input space, the model even perform worse. So maybe there's some problem with its generalization. And on contrary, the proposed model, CATS, definitely perform very well when you fit the additional introduction and the conclusion for the model to summarize. And it definitely achieves the state of the art in this data set. And let's compare with the Barr model. The Barr model is like perform quite well, but definitely not comparable for their proposed model. Their proposed model is still around 1% higher than that in terms of RUG score. Even if let me maybe explain the CAT model. The framework of CAT model I already introduced is they use the title as scaffolding, and the model they use to generate the summarization, it's also the BART, but the training objective is different. So that's why you can see how the title scaffolding is helpful. And this XSUM means they fine-tune on the XSUM dataset. They use the Barr model, they fine-tune on the XSUM dataset, and then fine-tune on their too-long didn't read dataset. And this is basically means their assumption is XSUM dataset maybe can help they generate a too-long didn't read for the science paper better. Even XSUM is news dataset. Okay, so that's the result. Basically achieve the state of the art in this dataset on all categories. Very, very impressive. This is some example of the model generated result. This is the author generated too-long didn't read and peer review one, and you can see the model, the Barr and the CATS generated. They both score 40 RUG score in this paper, and just give some sense of it. And in general, CAT is a better model. It performs better in terms of RUG score. Finally, let's just try it out how too-long didn't read looks like in a Semantic Scholar. So let's say I want to search text segmentation. I want to research this topic. Then there will be a lot of too-long didn't read for a paper. We present blah blah blah. And in general, too-long didn't read it's around 20 words, which is super optimal for you to quick skim the paper, right? Like text is a method of splitting for a smaller part. Looks like this too-long didn't read. It's not really helpful. For example, this is a survey paper. It's a review, and it just says text segmentation. It just explains text segmentation, but actually this is too-long didn't read for this should be, this is a review for text segmentation. I guess it's just not really workable for review paper or survey paper. And if this is a standard paper, we can see, they propose a way CNN bidirectional LSTM models to do something for that. And I can get a concept of the paper very quickly. Somehow helpful? If you find this video too long and didn't watch, here are 3 points that you can take away. This paper's contributions, they introduce the too-long didn't read summarizations to the summarization big family. And they basically annotate a data set for too-long didn't read training called Science too long didn't read. It contains quite a lot of too long didn't reads, 5,000. It's not a lot, but it's very hard to generate. And the proposed methods you can train your model. It's basically like a framework. It's a learning objective using title as a scaffolding generating goal. And you can plug in any kind of models for that. For example, in this paper, they plug in BART, but you definitely can plug in GPT-3 or even more powerful language model, maybe GPT-20. So that's very, very interesting way to summarize scientists' papers. And I hope this too long didn't read can let us, a lot of scientists, save more time. If you enjoyed the video, give it a like and don't forget to subscribe for more relevant deep learning videos like this. And other than that, take care. Until next time.